GameSci.com. GameSci.com. Welcome to GameSci.com. I am Professor Chris Ferguson. Enjoy the course.
Hello, and welcome to the lesson on methods, also known as functions, subroutines, procedures. There's various different names they go by. It's generally dependent on the language you're programming. Java, because it's object-oriented, and methods implies object-oriented programming, uses the term methods. C in JavaScript, like functions. Basic and assembly language likes the term subroutine. Whatever you call it, a function, a subroutine, a procedure, if you know what those are, you know what a method is. A method is a chunk of code that we can call from different parts of the program. Basically, we want to break our large problems into small problems. We never want to program with one big giant block of code. We want to take that block of code and break it up into smaller pieces. The idea comes from math. In math class, how do they teach you to solve a large problem? Break that problem into smaller pieces. And it's almost universally considered a good practice in computer programming to break up large pieces of code into smaller pieces. And those smaller pieces that we break up into, those are the methods. And again, method is an object-oriented term. When I hear the term method, I think, well, that's a function that's part of an object. So I've boxed out a method called AnyMethod. This example is purposely generic. I want you to focus on the idea of a method and the mechanisms for building a method. I don't want you to focus on a specific piece of code now. So I've boxed out the method. It starts with public static int, and I called it AnyMethod. Again, this is very generic code. I want you to focus on the mechanisms of creating a method, not on a specific piece of code. First up, we're going to learn some terms. And what I'm going to do is I'm going to box out the term down below, header, and then underline or somehow highlight the corresponding thing above. So you can see I've said the method header is here at the top of the method. Public static int AnyMeth int parm1. That is the method header. You can almost think of this as the declaration of the method. This is not an executable line, but a declaration that says what is the name of the method, what is the input of the method, what is the output of the method. This is called the method header. Next up is the body of the method. The body of the method is the executable code of the method. Remember how I said the method was breaking the code up into smaller chunks? Well, this is the chunk of code I want to execute when the method runs. The method body is the executable code that runs when the method is called. You can also see the method body is contained in between the curly braces of the method. The method body is the code between these curly braces. This curly brace is considered the start of the method, and this curly brace is considered the end of the method. And the code in between is considered the body of the method. Next up is the call of the method. Try not to confuse this with the header. Beginning students often get the call and the header confused. The call is definitely an executable line of code. The call says at this point in the program, I want to go run that method. What's going to happen here is this code, when the call executes, is going to jump up and execute the method. So this is considered the call of any method. It says I want to jump and execute this code up here. Argument. The argument is a value passed to the method so that it can do its job. It's input to the method. This value 27 is the argument, and it's going to be set to this parm1 parameter up here. It's the input to the method. A value passed to the method so it can do its job. That is the argument to the method. Not to be confused with the parameter. The parameter is the input to the method. Int parm1 is the parameter to this method. The argument 27 will be assigned to this parameter. Parameters are input to the method. Return type. Some methods, not all, return things to the caller. I am going to send back an int. What this box is telling you is the method AnyMethod will return an int. When it's done completing its job, it will send back an int to the caller. And you can see I'm using the int returned back by this equal sign. Finally, the return value. In this case, the return value is clearly 0. This method promised it was going to send back an int, And since int is a 0, it will send it back. Int is the return type. 0 is the value that is sent back from the method when it's done. And what will they do with that return value when it gets done? That's where that equal sign comes back. What this code is showing you is I'm going to send 27 as the input to the method so it can do its job. And when the method is done, it will send the 0 back and assign it to the return value. Let's trace some code and see how the mechanics of this works. I think it's always easier when we can see what it does. First up is the call to the method. We're going to call any method and pass it an argument of 27. This 27 will be passed to the method and assigned to parm1. You can see over here that a 27 showed up into the variable parm1 before the execution of this code. Remember, a method is a block of code that we can execute from different parts of the code, and that's what we're doing here. We're saying at this point in time, I want to jump and execute the code in any method. That's what a call does. So the body of the method will execute. And again, I don't want you to focus on anything specific here. I want you to understand that when it's time to call the method, the code inside the method between the curly braces will execute. When that code completes, it'll execute a return. This return is a requirement. Why is this return a requirement? Because the method promised to send back an integer. And in this case, it decided to send back a 0 as the value or a return value for the method. So it's going to send back the return value. Now, who gets that 0? Well, if you come down here, notice the equal sign. After the call to any method, I want to take what it returns and assign it to this variable here. Bang! Any method returned is 0 and it got assigned to the variable return value. Notice how that 0 showed up in return value. There you have it. There's one simple call. When the method is done, the program will pick up after this line of code and continue on. Methods, also known as subroutines. Methods is sort of an object-oriented term. We tend to call these things methods when we're dealing with objects. We use terms like subroutines and functions for programming languages that aren't using objects. One of the primary goals of a method is to write once and use many times. If I have a piece of code that I want to execute many times throughout the code, well, I don't want to copy and paste that code over and over again. I'd rather write that code once and then call it from several different places in the code. And methods allow us to do that, to write the code once and use it for many different places in the code. So I've boxed out the method here. At this point, when you think of methods, I want you to kind of find sort of three different things. I want you to consider the method header. What part of this is the method header? Well, it's that first line that starts with public static void. What's the method body? The method body is the executable code between the curly braces in the box. And what is method call? The method call is later in the code, someplace else where you call and execute the method. When you see a program and you look at methods, I want you to kind of identify those three pieces. The method header, the method body, and the method calls. There's a method call here. There's a method call here. There's a method call here. Let's trace some code. Let's see how it works. Best way to learn is to watch it in action. This is definitely a call to a method. At this point in the code, I want to stop executing the code I'm running, suspend my execution, and jump to the method and run its code. So we're passing some arguments of 0 and 100. You can see that the first argument, 0, gets assigned to the first parameter, score 2, and a 0 shows up in the score 2 variable. The second argument, 100, gets assigned to the second parameter, health 2, and the 100 shows up in the parameter health 2. After we pass the parameters, we execute the body of the method. The body of the method is the code between the curly braces. We're going to update the screen. We're going to draw out what the current player score is and what the current health value of the player is, and we want to update on the screen, letting our user know what their score and health value are. This looks to me like the start of a level, right? This looks at me at the start of the game. Your score is 0, you haven't acquired any points, and you're at full health 100. The start of the game, we're going to tell the user this is where you're starting from. But as we know, as the game continues, what's going to happen? Well, the score hopefully is going to go up. The health is definitely going to go down. These things happen in a video game. Your scores go up and your health points go down. So many different places in the code, we're going to have to call update screen to report the new values. As this method finishes, when it hits this curly brace, that is the end of the method. When it finishes this method, it will go and execute the line of code after the call to update screen. So if it comes to the code after update screen, it's going to set a score equal to 20 and a health equals 72. When that code executes, you can see that score got the value of 20 and health got the value of 72. Also notice I drew an X across the parameters. One of the things I want you to know about parameters is they refresh or they restart every time you call the method. Just because you had a value in score 2 before when you ran the method doesn't mean you'll get the same value in score 2 when you come back. So we'll see that very shortly. We're going to call update screen again. Update screen is going to cast the value in the variable score, which is 20, and pass that to score 2, and you can see the 20 showed up here. The first argument was the variable score, which had a 20. That 20 got assigned to score 2. The second argument, health, the value in health, 72, got passed as an argument to the variable health 2, and you can see a 72 showed up. That's what passing parameters do. They assign values to your parameters. With those values in the parameters, when we execute the body of the method right here, the score 2 value, which is now 20, will show up on our output, and the health 2 value, which is 72, will show up on our output. You see what happened there? I said at this point in the code, I want you to output the current score and health for this player. When the body of the method completes, we hit the end of the method. And what happens at the end of the method? Get used to this. At the end of the method, it jumps back to the code that called it, and it goes to the line after the call to the method. And the line of the code after the call to the method is this third call to update screen. It's going to jump down to the third call to update screen. And now I'm going to show you a different way to pass arguments. I'm going to call update screen, and I'm going to pass it score plus 10. Parameter is an integer. It doesn't care where the integer comes from. We've saw it 3 different ways here. We passed it constant value, 0. We passed it the value stored in the variable. Now we're going to pass it the value, the result of a mathematical equation, arithmetic. We're going to take the value of score, which is 20, add 10 to it to get 30, and pass that as the argument to score 2. And you can see 30 showed up in score 2. We're going to take the value in the health variable, which is 72, subtract 4, which makes 68, and pass 68 to the health 2 variable. And you can see 68 showed up in the variable. Which means when update screen executes the body of the code, it's going to use different values for score 2 and health 2. 30 will show up as the value of score, and 68 will show up as the value of health. There you have it. One of the things I'm showing in this code is every time I call update screen, I can pass it different values. That's part of the power of a method. It doesn't have to do exactly the same thing every time. Through the use of arguments and parameters, I can have this method be useful in several parts of the code, not just at the beginning to print out 0 and 100. And of course, when we reach the end of the method, the code will return to the line of code after the call to update screen, which means the program's going to continue on. Now let's kind of back up here and talk about why do we want to write methods? When you write once and use many times, you'll find when you want to make changes, you only have to make them one time rather than multiple times. For instance, if I'd done my system.out print line here 15 different places in my code, and I ever wanted to change this message, that's 15 lines of code that I'd have to change. However, when I put this code in a method and I call that method 15 times, well, I only have to change this method once, and I can change everywhere I output the message. So I decided to switch my output to Spanish. Not sure why I do that, but I decided instead of printing score and health, I wanted the Spanish words to print for score and health. In a method, I change this one line of code one place, and everywhere I make the call, the output would change. I don't have to go to 15 different places where I wrote to the screen. I go to one place where I updated the screen and change it. Changing something once is a lot better than changing it 15 times. Let's switch the language to French. I want to write a French version of your game. So, les score, that looks pretty obvious. Santé. I went to Google Translator here. I'm hoping that's the word for health in French. I'm switching the language to French now. Again, I change this one line of code, and everywhere I output the score and health, it updates to outputting in French. Let's say there were 100 places in the code where I was outputting the message. This is your current score. This is your current health. If I put this print statement in 100 different spots to change the language, that's 100 different edits I have to make. If I put this code in a method and call that method 100 times, then I only have to change one spot in the code. This is one of the things you learn through experience, right? When you've took some code and you didn't put it in a method and you had to go back and change it and you just regretted having to change all these other places of code. And then you tell yourself, man, I wish I would have put that code in a method and then I would have only had to change it once instead of 100 times. Parameters and return values. Methods get input. The input to the methods are called parameters. There's a reason why I put the word input exactly below the word parameter. Parameters are input to the methods, values sent to the method so it can do its job. Return values. Return values are output of a method. Return values, if the method has a return type, in this case double, the return value is the value sent back from the method. Parameters and return values allow you to use your methods in much more flexible manner than without using parameters and return values. But the bottom line is this: parameters are input to the method so it can do its job. Return values are output from the method so it can call the calling code and tell it what happened. So let's trace the code. Let's do a real video game example this time. We want to calculate damage. We all know damage is related to the amount of armor the player has. If the player has a lot of armor, then a shot to it will do little damage. If the player has little armor, then a shot to that player will cause lots of damage. There's hundreds of different places in the code where I might need to calculate, well, how much damage did this occur? How much pain did this shot take? Well, that's a perfect place to use a method. Let's isolate the code to calculate how much damage occurs depending on the armor the person has in one spot. Therefore, if I ever want to adjust it, I only have to change it in one spot. Let's start with some initial values in the variable health of 93, in armor of 55, and in damage of 8. And let's trace the code and see what happens. First up on this line of code, I'm going to call calc damage. This is a call to the method calc damage. My current value of armor, which is 55, will be set to the variable arm. The first argument is assigned to the first parameter, and a 55 shows up in arm. The second argument, damage, is passed to the second parameter, damage. Ooh, what's that? The parameter has the same name as the argument? It's actually legal. Parameters are local variables, and local variables can have the same name as other variables. This local variable is only good inside here. When we're dealing with the parameter damage, we will be dealing with the value that passed from here. I myself prefer to name my parameters slightly different than what I pass to them, but it is perfectly legal, and you'll see it over and over again, to name your parameters with the same name as the variable being passed to them. What's more important is to understand the values. There was a value in this damage variable of 8, and it was passed and assigned to this damage variable, so we see an 8 showing up there. And again, based on the amount of armor, we want to adjust the amount of damage that occurs to the character in this video game. If arm is less than 10, if my armor percentage or my armor value is low, then I'm going to take a lot of damage when I take a hit. 55 less than 10 is a false statement, so I have a fair amount of armor. As a false statement, I will fall through to this next if statement and check it. 55 greater than 10 is very much a true statement. It looks like I have a medium amount of armor. I have a little bit of armor. What I want to do is calculate my damage at 50%. If I have a medium amount of armor and I take a shot, I don't take the full damage of the shot, but I do take some damage. I'm going to take the damage input, 8, which would have happened if I had no armor whatsoever, and cut it in half. By multiplying it by 5, I'm going to cut it in half. 8 times 5 is 4.0. So I'm saying with a medium amount of armor, and I take a shot that should do 8 points of damage, I should reduce that to 4 points of damage. More armor, less damage. Less armor, more damage. And that's what this code is trying to do. Medium armor, medium or half the damage should occur. This return statement, this output of the method, is going to return back a 4. My input was 8, but this method's calc damage decided I should cut that in half to 4. Well, 4 will be sent back to the calling routine. Well, see the arrow? The arrow is pointing to where we called calc damage. A 4 will be sent back to here. Our current value of health is 93. We subtract a 4, and after taking that shot with medium armor, it's decided that the health value should be updated to 89. Makes sense? That's a pure video game example. If you have no armor and you get shot, you should take full damage. If you have half armor and you take a shot, you should take half damage. Let's run it again and let's bump up the armor. Let's say we've been picking up a lot of armor and we shouldn't be taking a whole lot of damage when we get shot. We're going to run it again with new values in the variable for armor and new values in the variable damage. Damage could be different. It depends on what you get shot with. It depends on what hits your character. If you get hit with a pillow, the initial damage assessment should be low. If you get hit with a grenade, the damage assessment should be high. We're going to adjust just those two variables. Notice how health is still 89. We're trying to simulate this idea of we got hit a second time. What should our damage be? Let's call the method. The current value of armor, 92, will be passed to the parameter arm, and you can see the 92 shows up there. The current damage assessment of 10 will be sent to the parameter damage. Again, the parameter could have the same name as the variable that is passed to it. Do keep in mind these two variables are different. This local parameter damage is different than this variable damage. But the value 10 was transferred to that variable, so you see a 10 showing up. So I passed a 92 and a 10 to it, and let's see how this works. Well, 92 is a lot of armor. 92 less than 10 is a false statement, so I'm certainly not going to take full damage. So let's go down to the next if statement and test it. 92 less than 60 is still a false statement. I have more than a medium amount of armor, so I'm not going to take half damage on this hit. Fall down to this if statement, and it's 92 less than 95, which is a true statement. I have a lot of armor. I don't have full armor, but I have a lot. What I'm going to do on this is calculate a little damage. Remember, my input to damage was 10, but I have a large amount of armor, so I'm only going to assess myself 10% of that damage. I'm going to say, okay, when you take a shot that would have taken 10 from your health point, but you have a lot of armor, I'm only going to return a penalty or a damage assessment of 1. You see what happens? When you get shot with a lot of armor, it should do less damage, and it clearly is doing it. The 1 that got sent back from calc damage is subtracted from the current value of health, 89, and you can see even though I took a significant shot, because I had a lot of armor, I took very little damage. There's my new value, 88. Now, did this method make sense to you? If I have no armor, a shot should give me full damage. If I have an incredibly a lot armor, a shot should take no damage. But somewhere in between, I want various degrees of damage to take place on my character, depending on the amount of armor. Global versus local variables. There are two very different types of variables. There are variables declared at the top of your code outside the method that are called global. And then there are variables that are declared inside your method that are called local. And these two variables act and behave very differently. So it's important to understand the difference between global and local variables. The top here in the box, I'm going to declare an int x position and an int y position. Now I don't have room to show you the whole program. All I'm going to specify is that these two variables are declared at the top of the class outside of a method, and that makes them global variables. Put it at the top of your code outside the method, and they will be global variables. And they will behave differently than local variables. Local variables are declared inside a method, including parameters. I've boxed in this int x difference. Because that's declared inside move x, this will be a local variable to move x. I've also boxed in int x new. Because this is declared inside of move x, it will be a local variable. See the difference? These two are outside of a method, they're global variables. These two are inside of a method, they're what's known as local variables. In move y, we have the same thing. In move y, we have an int y difference. It is clearly declared inside of move y, so it is a local variable. Int y new, clearly declared inside of move y, so it becomes a local variable. Globals are declared at the top. Locals are declared inside of a method. Let's run this code and see what happens. Run the method with some initial values in the global variables. We'll put a 5 in the x position variable, and we'll put a 580 in the y position variable. And that just means my character is located at position 580, or x is 5, y is 580. Move x and move y obviously are there to be methods to move my character across the screen. Let's see how move x and move y work. We're going to call move x and pass it a parameter of -8. -8 says subtract 8 from my current player's x position, which says move to the left or move towards the 0 x coordinate of the screen. So I just want my character to move left 8 units. What happens here when I make this call is -8 is the argument that I'm sending to move x, and -8 shows up in the x different variable. Now something new just happened there. If you weren't paying attention, these variables just sprang up. And they sprang up for a reason. Local variables are created on demand. The variable xdiff is created when I called move x. The variable xnew was created when I called move x. Local variables are created when you call the method. They don't exist forever. They get created when you call the method. The argument -8 was assigned to the local variable xdiff. I fall down and execute the body of the function. X position, which is a global variable that contains a 5, is added to x difference, which is a local variable -8. 5 plus -8 is a -3. The result here is -3. What are we going to do with that -3? We're going to assign it to the local variable x new. The -3 that was calculated gets assigned to x new, and you can see that it showed up here on x new. Interesting. What we've asked this character to do is to move to a new position at -3 on the screen. Next up, I'm going to do some checking. Let's say our game was played in an 800 by 600 screen. That is a popular monitor resolution. I want 800 pixels on the x-axis, and I want 600 pixels on the y-axis. Typically when that happens, 0, 0 is this coordinate on the screen, and 799 and 599 is this bottom right corner of the screen. I want my character to always be on the screen. Think of the cursor as my character. Am I moving this way on a video game screen? When I get to the edge of the screen, I'd rather it stop. I don't want it to keep moving. So what we're going to do with this code is we're going to make sure that if my x position gets to 0, I'll stop there. Or if my x position gets to the other side of the screen, I'll stop there. Let's call this a two-dimensional Mario style game, and the character is to stay on the screen at all times, never go off the edge. That's what this code is doing. It's saying if my x new is greater than 0, which is good, I'm on the screen, return true. And if my x new is less than 800, which means I'm over here, then I'm good. If I'm between coordinates 0 and 800, that's good and set X position. However, we calculated -3 in X new. A -3 in X new would have my character going off the edge of the screen. I do not want my character to disappear off the edge of the screen. This false statement here, X new greater than 0, says do not change the position of the screen. Skip this X position equals X new and go to the end of the routine. See why we're putting this in a method? Many places in the code we're going to have our character move. I do not want my character moving off the edge of the screen, so I have my move method check, and when it decides that it's not a wise move, it jumps back and says continue on the code. Also notice we just lost our local variables. They just disappeared. Why'd that happen? Well, there's a different rule for local variables. Local variables are created when the method runs. They're deleted when the method finishes. Local variables are created on demand. They're created when the method runs. They're deleted when the method exits. My local variables went away. What happened to the global variables? They stuck around. Remember, the rules are different between globals and local variables. Globals stick around. They stay at all times. Locals get created and deleted on demand when the method is running. Now I'm going to run move y, the other method here, and notice how the global variables x position and y position stay their current values. They're not deleted. And let's call move y. When I call move y, we'll pass 5 as the argument and assign it to y difference. Notice how my local variables y diff and y new were created on demand. I can't stress that enough. Local variables are created when the method runs. So that's what I just did. I created these local variables as soon as the method runs. A 5, my argument, was assigned to y diff. I jump down to the next line of code. You'll see I'll access the global variable y position 580 from that variable. I'll access the parameter y diff 5 from that variable, and the result 585 is calculated. What do I do with that result 585? I assign it to the local variable y new. The local variable y new gets the value 585. Now the reason I'm calculating it this way is I want to make sure that value is good. Once again, I told you I do not want my character going off the screen. The screen is 800 on the x-axis, 600 on the y-axis, and I don't want my character disappearing. The y-axis of 0 is up here. When I reach the top of the screen, I don't want to go off the top of the screen. Same for the bottom of the screen. When I reach the bottom of the screen, I don't want my character moving off. So I'm having move x and move I verify that the new y position is okay before I go ahead and set it. 580 greater than 0 is a true statement. I haven't gone off the top of the screen. 580 less than 600 is a true statement. I haven't gone off the bottom of the screen. It looks to me that the new value for y that has been calculated is within the range that I want, between 0 and 600. Since it's between the range 0 and 600, I need to execute the code in the if statement. When I execute the code in the if statement, the value in y new 585 just got transferred to y position and y position update. My character could then move to this new position. Notice how when move y finished, my local variables disappeared. That's what locals do. They get created when the method is run. They disappear when the method is completed. My local variables went away. But what didn't go away? My global variables didn't. Global variables stick around. That's why we like to store some information into them. The current location of the player, their current x and y position, we want that to stick around. We do not want that to be. So we return to after the call to move y. Now before we leave this slide, I want to make 3 differences about global variables abundantly clear. Globals are declared outside of a method at the top of the class. Locals are declared inside the method. The global declared outside the method, hopefully at the top of the class. Turns out I got a little secret for you. Globals could be declared in the middle. They can be declared at the end, but I greatly prefer them at the top. I think people that declare them at the end of the class are kind of weird, if you know what I mean. So let's just, for my sake, in this class, declare our global variables at the top of the class. Local variables are very different. They're declared inside of a method, and parameters are local variables. So here are my globals. They're declared at the top. Here are my local variables. They're declared inside the method. The next difference is called the scope. The global scope says I want to be able to use X and Y position in all my methods. Now there's a reason I made X and Y position bold. See that bold font? See the bold font for X position here? See the bold font for X position here? See the bold font for Y position here? This X position variable, I'm accessing that variable right here. This Y position variable, it's bold. That bold Y position is where I'm accessing that global variable. I wanted to make the global variables look at least a little different than the local variables. X and Y position are good in this method and that method and a whole lot of other methods. Global variables are called global because they're good in all the methods. Local variables are different. They're only good in their own method. When I declare X new and X difference inside of MoveX, X new and X difference are only good inside of MoveX. Remember, they're not even created until MoveX runs, so they're certainly not available outside of MoveX. Also, the local Y new and Y diff are only accessible inside of MoveY. Again, they're not even created until MoveY runs, so you certainly couldn't use Y difference inside a different method like MoveX. Local variables are what the word local means. They're local to this piece of code, the code that created it. And finally, the lifetime of the variable. The global lifetime is while the program is running. The locals are created and deleted on demand. They only exist while the method is running. So see these global variables, X position and Y position? They're created when the program runs. At the very beginning of the execution of the program, X and Y position were created. They won't be deleted until the program ends. When you terminate this program, that's when the global variables disappear. That's why they've stayed on the screen the entire time. As soon as the program ran, these are created. They will not go away until the program is completely done. Locals are very different. Locals are created when the method runs. When we executed MoveX, X difference and X new were created. And they're deleted when the method ends. Lifetime refers to the length of time or the amount of code where that variable is good. Pass by value, which says make a copy of the parameter, or the parameter is a copy. Also known as call by value. Some books call this call by value, some books call this pass by value. Either way, what you want to know is the parameter is a copy of the argument. So let's create a global variable, static double money equals 20. You can see over here in my global memory, I've allocated the variable money and it has a value of 20.0. So my current player has 20 bucks in their pocket. Let's execute some code from another method. This code is outside the method and it will be calling display money. Before the method is called, we'll print out what's the value of the money variable. And you can see the 20 was taken from the global variable and it shows right up here on the output. So before calling the method, we had $20 in our pocket. Now we're going to call the display money method. The purpose of the display money method is to print to the user how much cash they have. Now what you have to understand that cash is a copy of money. Pass by value says don't send the actual variable money, send a copy of the value. So the value was 20, it got copied to the variable cash. As local variables do, cash was created as soon as I called this method. You can see cash was created there, and the value of money was copied to it. Cash is literally a copy of money. When I print out cash on hand, you can see the copy 20 was output to cash on hand. Now I'm going to change the copy. I'm going to say cash equals 0 0.0. When I say cash equals 0 0.0, it's important to note I changed the local variable cash to 0 0.0. What did I not change? I did not change the variable money. The variable money stays 20.0. Nothing happened to it. I changed this variable, which is entirely different than that variable. It once was a copy, 20, but now it is different. When the method is complete, it will return to the line of code after the call to display method. Watch what happens to the copy when display money is done. I delayed the deleting of the variable to show you that we clearly deleted that local variable cash after we returned from display money. The copy disappeared. What didn't disappear? The global variable money. Also, what didn't change? The global variable money. The original value that was stored in money that I'm printing right here, 20, stayed 20. That's pass by value. That's the advantage of pass by value. You can send a variable to a method, and as long as it's pass by value, they cannot change that variable. If it was 20 before I call display money, it will be 20 after the call to display money. Pass by value says the parameter is a copy. This double cash, you got to think of that as a copy of the parameter. Pass by value says the parameter is a copy of the variable passed to the method. There is no way to change the original variable that was sent. Basic data types like int, double, char, etc. are always pass by value. Whenever I make a call like this, call display money and pass it my global variable money, I'm well aware that that value will not change. Nothing can modify this variable money when you do pass by value. Pass by reference is the alternative to pass by value. That's when the parameter is not a copy of the variable passed, and that's when changes do affect the original. Now, I did not show it to you this example because objects are passed by reference. And we haven't gotten to the lesson on objects yet, so it's really hard to show you how objects are passed by reference. However, when we get to objects, we will talk about pass by reference. It's a significant difference between passing an int or a double as a parameter and passing an object as a parameter. Basic simple data types like int, double, and char are always passed by value. Objects are passed by reference. Globals versus parameters. Global versus parameter. In order for a method to be effective, we have to have a way to get information into the method as input and information out of the method as output. Let's look at two different options for doing input and output on a method. Option A says you can use a parameter for the input and a return value for the output. This version of bump level uses a parameter for input and a return value for output. Option B says you can use a global variable for input and output. This version of bump level uses a global variable for input and output. Once again, let's trace the code and see how this works. We're going to declare a static int level equals 1. This is a global variable available in all the methods, and we're going to set it an initial value of 1. At the start of the game, you would expect to be at level 1. But during the execution of the game, you would expect this level to go up as you complete the levels to 2, to 3, to 4, and so on. So let's look at both ways a method can access this variable and bump the level of the game we're playing. First, we'll look at option A. Use parameters as input to the method. I'm going to send the value of the global variable level 1, and it will become a copy in the parameter lev or lev. Remember, this is pass by value. This will be a copy of the current value in the level global variable. When I bump lev plus plus says add 1 to the variable lev, when I bump that to 2, what's going to happen is the copy changes to 2. The original, of course, does not. Pass by value says this is a copy. I've changed the copy to 2. What I'm going to do is return the copy. I'm going to say return the value in the lev parameter. Remember, we're doing option A. Send the return value 2 back as output from the method. Return type and return value provide output from the method. I will send this local variable 2 back to the calling routine as output. And where is it going to go? It's going to go to this equal sign. Bump level, this call, has returned a 2. What do I do with that 2? I take the 2 that it returned and I update my global variable using the return value 2. The 2 gets sent to the global variable level, just as you would expect bump level to work. I sent in the current level as input, a parameter. I got the output and updated the global variable using the output. Now, that's not the only way to get information into and out of a method. Your second option for getting information into and out of, option B, is to use the current value of global variables as input and use the values of global variables after the method call as output. So option B says use current global value of 2 as input. This is called a precondition. Before I called bump level, the global variable contained a 2. Well, if I access that global variable inside the method, it becomes my input. When I say level equal 1, it'll execute 2 plus 1. This 2 that came in the global variable, that's input to my method. Level 2 is set before the call. It is input to the method. So I'll do the calculation 2 plus 1 and get a 3. What will I do with that 3? I will assign it to the global variable. Again, we're doing option B here. The global level is set to 3 after the method call. This becomes its output. That's what's known as a post condition. Before the call to this bump level, we had a 2 in the global variable. After the call, we have a 3. That's input and output, folks. Now, since we have these two choices, do you want to use parameters and return value for input and output, or do you want to use global variables? Let's look at when you use them. Number one, parameters and return values are generally considered better programming practice. Nothing is absolute here, but given a choice, parameters and return values are considered better programming practice than using global variables. We want to use global variables sparingly. Too many global variables is too much. If I look at a program and it's got 100 global variables at the top, I think that's a mess. You can't have that many global variables at the top. The global variables are for only the most critical, important information there is. If you find yourself declaring everything a global variable, it's wrong. We want to use global variables sparingly. Parameters and return values are considered better programming practice. The third point I'll make is experience is the better teacher. Once you've programmed a while and dealt with the deal of global variables versus parameters, you'll get the hang of when to use parameters and return values and when to use global variables. All I can stress is don't overuse global variables. If you continually use global variables for input and output to parameters, you're going to end up with 100 of them, and that is bad. Well, I hope you enjoyed that lesson. Once again, I'm Professor Chris Ferguson. Please visit us at gamesci.com to see more interesting lessons.